All right, so I'm going to take you through um, some problems on section number 12. So quickly, let me show you how to get that file. So go to modules when you're in the course homepage. All right, and then scroll down and look for summary worksheets. All right, now when you find summary worksheets, go to session 10. All right, and then open this file. You may decide to download it. All right, and this is what you should expect to see. I downloaded the file, so I'm going to share the file with you right away. So I'm going to stop this and share the Excel sheet with you. Okay, nice. All right, so let's look at these problems on section number 12. So far we've been looking at the financial section, section 10 that spoke about credit cards. Section 11 spoke about loans. All right, where we looked at the application of PMT and the present value function, which is PV, right? We said that PMT is used to estimate the monthly payment, and PV is used to estimate how much of a mortgage you can afford when you know the monthly payment. Is that okay? Now, we are going to introduce a third Excel function that is called the future value function to deal with retirement. Okay, so if you already watched the section video on section number 12, let's look at these problems together. Okay, so it says number one, Johnny has a job that earns 4,000 gross pay monthly, right? Taxes at 20%, and he contributes 200 towards his retirement. Now, if his job matches 30% of his contribution, we want to answer the questions that follow. Now, we want to know how much is his take-home pay after the contribution and taxes. Is that okay? So the key thing that you need to know here to solve this problem is that 401k contributions are deducted before taxes are applied. Is that okay? So we are going to do $400, $4,000, sorry, minus $200. And this is going to give us 3,800. So this is the taxable amount. Okay. You need to take away 401k contributions before you apply taxes. Is that okay? So this is the amount that is taxable. So I'll indicate the taxable amount. Is that okay? Nice. So now we want to know how much of this will go into taxes. So for taxes, we are going to do 20% taxes. So we will do 20% is 20 over 100, which is 0.2 multiplied by 3,800. Okay, and what do you get for that? So 0.2 times 3,800 gives you 760. Is that okay? So now to know Johnny's take home pay. So the take home pay is going to be the 3,800 minus 760. And what is that? So Johnny is going to take home 3,040. Okay, so that is how much Johnny is going to take home. Is that okay? So this is Johnny's take home pay after the contribution and taxes. Is that okay? Nice. So that's simplified. That solves the A part. Now, how much will Johnny contribute for 30 years? So you want to know Johnny's contribution and we want to know how much his employer will also contribute. So to know Johnny's contribution, so I'll do Johnny's contribution. Or let me do simply Johnny. We are going to do how much Johnny contributes. So Johnny actually contributes $200, and then he does that for 30 years. So we're going to do 200 by 12 because there are 12 months in a year, right? And then we will multiply by 30. And that is Johnny's contribution. Okay, can you do that multiplication real quick? So for the whole period of 30 years, Johnny is going to contribute that 72,000. Now let's know how much his employer will contribute. Okay, his employer will contribute. Now, his employer contributes 30%. So you have to do 30% of Johnny's contribution. So the employer contributes 30%. So 30% of 600 is how much Johnny's employer contributes every month on his behalf. Is that okay? So you realize that 30% of 200, okay? So I'm going to do 30% of 200. And what is that? That is $60. So Johnny's employer contributes $60 for him every month. So we do 60 by 12 and then by 30. And that is how much Johnny's employer will contribute for that 60-year period. Is that okay? Nice. Now it says write a ratio of what? Write a ratio of what? Write a ratio that represents the company's contribution to the total amount invested. Okay, so we want the company's contribution. So we want company's contribution divided by the total amount. So what we're doing is we want company's contribution over the total contribution. Okay, that's what we want. So company's contribution over the total. Now, how much does the company contribute? Okay, so the company contributes 21,600. Now we want the total here, so we put this and that together. Okay, and if we sum these two, we are getting 93,000. So we divide by 93,000. Okay, and you realize that that is about 23%. So this will give us 0.23, which is about 23%. Okay, so the company contributes about 23%, all right, of the total money that goes towards Johnny's retirement account. Are we Gucci? All right, so that is for the C part. Now let's go to D. You want to find the total in the retirement account for Johnny after 30 years with an APR of 6.55. So you have to go by the FV function. So you do equal sign FV, and then the rate is, you change that to a decimal, as you know, divide by 12, and then do 12 by 30, and then minus. We want to know altogether how much will go into his account. So you realize Johnny is contributing 200, his company is contributing $60. So altogether we will have 260 right there. And that is how much goes into the retirement account. So if you do this every function in Excel, okay, that should give you the total amount at the end of the retirement period. So find the total in the retirement account for Johnny after 30 years. Okay, so would you want me to do that? Okay, so let's see. Now, if you put this function in Excel correctly as it is, Excel should generate how much will be in the account over the period. And Excel will generate 290,416.73. Okay, is that right? So now, if you want to know how much interest is in the account after, so we look at E, how much interest is in the account. Now, this is the balance after 30 years. So you're going to do the balance after 30 years. Okay, 0.73 minus the total contribution that went into his account, which is 93,000. Okay, and that will be the interest at the end of the day. Are you Gucci? All right, so this is the interest at the end of the period. So 19741.6 and 73. Okay, so that's the interest that accrued, all right, over 30 years for Johnny. Okay, nice. Now let's go to F. Now, how much more was in the account than what Johnny deposited? All right, how much more was in the account than what Johnny deposited? So we will look at the whole balance. So this is different, right? And this time we are going to subtract what Johnny contributed. So what was Johnny's contribution? All right, so we know that Johnny would have contributed 72,000. So invariably we mean without the company's contribution. Okay, so you do 290,416.73 minus 72,000. Okay, and this is how much will be in the account. Then he contributed. Okay, so that's the amount. So you realize that this question is different from that. Okay, so here you're looking at together Johnny's contribution in addition to the employer's contribution, right? Take that out, and that is the interest at the end of the period. But now we want to know how much more than what he contributed. So we just take out his contribution, and that gives us that. Okay, nice. Now let's go to number 2. I may show you how to do this in Excel as well. So you want to consider the following: $400 APR of that for 45 years. Find the amount in the account after 45 years. So you do equal sign FV, and then the rate is 0.0385 divided by 12, and then 12 by 45 years minus the 400 contribution. And that is what will give you the amount in the account after 45 years. Okay, is that okay? Nice. So let's see that. Let me show you how you can use Excel to do that. So let me quickly share this Excel file with you. I have an Excel file already opened. So really, if you want to do that, you do equal sign FV, right? And then you do 0.0385, okay? Divided by 12, comma, and then you have 12 times 45, okay? Minus the 400. Is that right? Nice. And Excel will give you that. Okay. So you need to actually expand. You need to open this up when these are closed. when the cell is very close, it will come out as an error. So be mindful. So make sure that this is opened, all right, so that you see the actual figures there. Okay, so we have that number to be 578. Okay, so 578,382.87 as the balance. So let's go there. Let's go back there and grab the question one more time. So that will be the balance at the end of the period. So Excel is going to give you that as 78,382 and 87. Okay, nice. Now, how much has the person deposited into the account? So if you want to know how much the person has deposited into the account, you do the monthly contributions multiplied by 12 and by 45 years. Okay, so you have 400 times 12 by 45, and the person would have contributed 216,000 into the account. Now you want to look at the interest that has accrued on that money. So you're going to do the balance at the end of the 45 years minus the total contribution. Seven eight 382.87, and that is 137617.13. Okay, and this is the interest over the period. Is that okay? This is fun, isn't it? Nice. Now you want to know number 3. Can we go to number 3 now? So how much interest is in an account with an APR of 3.99% for 42 years if Melinda deposits 375 each month? So first, you have to use the FV function to know the balance at the end of 42 years. So the 0.0399 divided by 12. Okay, and don't forget to introduce your comma, and then you do 12 by 42, and then how much Melinda deposits every month. Is that okay? And that gives you how much will be in the account. So if you want to know, so we actually want to find the interest. So you put this in Excel first. Is that okay? So let's go and put that in Excel and know the balance. So we'll put equal sign FV. All right, and then we do 0.0399 divided by 12, comma. Okay, and then do 12 by how many years? 42 years, right? Comma, minus 375. Okay, so you have the balance to be 488,146.87 as your balance. Okay, now let's go back and do the subtraction to find the interest. Okay, so to know the interest, now this is giving us that, okay, 488,146.87, okay, as the balance in the account at the end of the 42 years. Now to know the interest, you have to do the 146.87 minus how much Melinda would have deposited over 42 years. So this is 375 times the number of years. This is multiplication, so it's commutative. Okay, so what you do is 12 times 375 times 42 will give you, this is going to give you, okay, this right here is going to give you 189,000. Okay, so take that from 488,146.87, and then you have the interest to be 299,146.87, and this is the interest that would have accrued on Melinda's investment over 42 years. Okay, are you Gucci? Nice. Now, number 4, you want to find the profit of Kat's retirement account. He contributes 600 each month with an APR of that. He does this for 38 years, and his company does a 40% match. Okay, so his company, Kat's company, does 40%. So let's look at Kat's contribution. So Kat actually does 600 dollars every month, and Kat's company contributes 40% of what Kat contributes. So we're going to do 0.4 times Kat's contribution of 600. So Kat's company actually contributes 240 on his behalf every month. Is that okay? Nice. So that is what Kat and his company are contributing. Now, so altogether, how much will Kat and his company contribute? So you just add Kat's contribution plus his company. So altogether, they are contributing 840 into that account, right? So what's the question? We want to know the profit. So first of all, we are going to do equal sign FV and then do the APR 0.0525 divided by 12. And then we're going to do 12 multiplied by how long? This is for 38 years minus, so this plus that will go into Kat's retirement account. Is that okay? So that is 840 goes towards Kat's retirement. Is that okay? Good. So put this function in Excel and tell me what you got. Okay, whilst I do that here as well, I'm going to share my Excel one more time. And for Kurt, we do equal sign FV, and this is 0.0525 divided by 12, comma, all right. And then we do 12 by 38, comma, minus 840. That's a lot of money going into Kat's account. Okay, so Kat actually is going to get this at the end of the period, $1 million. Good money, isn't it? So 1,213,493.82. Okay, so that is how much goes into Kat's account. So let's see here. All right, so that amount is already there. So this is what that's what Excel gave us, right? Now we want to know the profit. Okay, so to know the profit, we are going to do the amount Excel gave us, which is 1,213,493 482 minus Kat's contribution. So Kat's contribution is going to be 600 times 12 and then by 38. Okay, so do that subtraction. And that will be profit for Kat. All right. So we are not talking about interest. We are talking about profit because what his company contributes is a profit for him, right? So in addition to whatever uh, money that the company, the investment yields. So 600 by 12 by 38, okay, which is 273,600. All right, so you take that from 121,349.82, and that comes out as 93,983.82, and this is the profit for Kurt at the end of 38 years. Is that okay? Sweet. So now let's go to number 5. How much money should be in a retirement account if someone contributes $250 for 20 years? The bank has given them a rate of that. So you just do equal sign FV. The rate is 2%. So 0.02 over 12. And then we have 12 by the number of years. Okay. And then minus 250. So do that. And whatever Excel gives you should be the money in the account after the period. Okay. Good. So that is for number 5. So we've been doing this all along. So please put that in Excel. And whatever balance you get is how much will be in the account after 20 years. Now here, you want to make up, can you make up the lost time by increasing your contribution? Find the total in each account. So just like we did in the discussion, the class discussion where we looked at Albert and Cain, you realize that Cain could not catch up with Albert. So here, what you're going to do here is you're going to use this contribution, this APR, and this number of years. All right. Now the person decides to double because he was half the time late. So he doubles up to 600 with the same APR. And right, 20 for 20 years. We want to see the total. So what you do here is that you're going to do equal sign V. Okay. And then you do the APR, which is 0.03 divided by 12. And then you do 12 by 40 years minus 300, okay, for this guy. And then for this other guy right here, you're gonna do FV, all right, equals sign FV. The rate is 0.03, still the same rate divided by that. And this time you're doing 12 by 20 years, but the amount is doubled to 600. So put these two in Excel and check the balances. All right, so you realize that. And what's the conclusion after you put these two in Excel? Okay, you're going to realize that though this guy tried to double the amount, it still wouldn't, catch up with this guy who has been contributing 300 for 40 years. Is that okay? So that's the time value of money. So the earlier, the better if you want to do 401k contributions. All right. So on this note, thank you very much for your audience, and I wish you good luck. All right. I'm out. Bye.